Hey guys, another video. Another experiment from the 100, 130 in one electronic project lab from Radioshack. So this one is experiment 89, operational amplifier winking led. Winking, yeah, as in blinking. Yeah, so this is an astable multivibrator. It's an oscillator that produces a square wave. So when you oscillate and produce a square wave, it's called an astable multivibrator. Okay, so let me just zoom. I'm gonna zoom on the text first because I never really. Okay, so this is the text that's supposed to explain what the circuit does, and it kind of explains how it works, but it's very succinct. I mean, there's not much explanation, so, but you get the idea. I mean, you have clues, if you will. Okay, so the circuit is the circuit, and I'll go to the bench to demonstrate how it works. Okay, so let me be one more time. Okay. Okay, so the basic idea is to use the op amp basic as a comparator. That's what you do. So on the plus input, we're gonna use a reference voltage. So V69, that's your reference voltage. In our case, if you look at the 9 volt up here, this is 9 volt up here, okay? Then you have a 10K resistor and a 10K resistor here that goes to the ground. So that's your typical voltage divider. So here, it's 4.5 volts, but it's also getting stuff from there's a feedback loop here. So it's getting stuff from the output. So if you look, this voltage is equal to this voltage, which is equal to that V69 at the positive input. So this is our reference voltage, V69. Now, V68. So this is basically controlling everything, because if V68 is lower than V69, the output at the V67, the voltage at the output, is gonna be in a high state. So it's gonna be positive saturation. It's gonna be 9 volt, probably 8 volt, but I will always say 9 volt, full source voltage. So if V68 is less than V69, V67 is going to be 9 volt. If V68 is greater than V69, the voltage at the output is going to be 0. I mean, not actually 0, probably more like 1 volt. But again, I always, when I talk about saturation, I always consider that it goes to the full source voltage. So in our case, either 9 volt or 0 volt. But in actuality, it's not really true. But it doesn't matter. Okay, so the heart of the whole thing is this guy, the capacitor. He's the one that's gonna, change the voltage here, and that's how the thing is gonna oscillate. It's gonna go between the high state and the low state, high state, low state, high state, low state. So if you look at the LED, and this LED is gonna demonstrate that you are either the output is at the high state or the low state, and this is demonstrated by the LED either being on or off. So if V67 is high state, so 9 volt, so you have 9 volt here, 9 volt there, there's not going to be current, so the LED is off. And if the output is at the low state, so V67 is 0, so you're going to have 0 here, 9 volt there, and the LED is going to be on. So that's how you, it's a way of seeing the state of the output, either low or high. You just look at how the LED, if the LED is on or off. Okay, so on means the output is a low state, and if it's off, output is high state. All right, so let's go to the bench and see how it works. Okay, I'm on the bench, the bench. So let's fire it up. It takes a while to oscillate. Okay, so this is the LED, so it's blinking. So when the LED is off, it means that the op amp is at positive saturation, and when the LED is on, it means that the op amp output is at negative saturation, that is 0 volt. So positive saturation is 9 volt, negative saturation is 0 volt. And that's pretty much all there is to it. So I think I'm going to go back to the other room and go over some whiteboards for you. Alright, see ya. Okay, so first whiteboard. So here I reproduce the circuit, the schematics in a simpler way. So you have the 9 volt, 10K, 10K, the voltage divider that feeds into the positive input. So 69 is the positive input. That's going to be our reference voltage for the comparator. And the output, and you have two loops going back. One goes back to 69, one goes back to 68, and the capacitor is here. So again, 69 is going to be our reference voltage for the comparator. Okay, so in order to explain how this thing works, you need to start with something. And I'm going to start with the op amp output being at the high state. That it meaning that the op amp is at positive saturation. So V out is 9 volt. So here, V out 9 volt. And I think it's good, maybe I should repeat this part here. And that's the way the op amp works as a comparator. So if V68 is less than V69, V67 is equal to 9, and if V68 is greater than V69, V out is 0. So that's the comparator business. Okay, so what is V69? This one, the reference voltage. And remember that we have 9 volt here, so we have 4.5, 9 volt. So it's going to be 4.5 plus something coming from this voltage difference. So there's a voltage drop here, so you get some stuff here. So that's why I'm putting the V69 as 4.5 plus epsilon. And that epsilon is probably pretty small because here you have 100K resistance in the path. Okay, so that's V69. So now we want to see what V68 looks like. So next one. Whiteboard número 2. Okay, so the same schematics, nothing has changed here. So what is this V68? So V68 is the voltage here at the positive side of the capacitor, right there. So what happens is that is seeing that 9 volt there, so because of this it's going to charge. It's going to charge towards the capacitor would like to charge all the way to 9 volt, but it can't, because as soon as it hits 4.5 volt plus epsilon, which is the voltage at V69, this one, the reference voltage, the output state is going to change. So as soon as V68 reaches V69, V67 output goes to negative saturation. So this is what V67 looks like now. So it was 9 volt and now it goes to 0. So now next question, what happens to the V69? What happens to the reference voltage? Next whiteboard. Okay, so what does V69 become? The reference voltage, V69. So it's gonna go to from 4.5 plus epsilon to 4.5 minus epsilon. Because so now you're at 0. This is 4.5. So now you go, the voltage is gonna go below 4.5. Same idea as before, but now below. So it goes to 4.5 minus epsilon. And what happens to V68? What happens to V68? The capacitor is going to discharge. The capacitor is going to discharge. So it's going to look like this. It's discharging. The capacitor really would like to discharge all the way to 0, but it's not going to happen because as soon as it hits 4.5 volt minus epsilon, the output is going to change. It's going to go to positive saturation. Okay, here you can see the discharge. 0, so plus discharge. Okay, next one. So, yeah, so what happens to V68? And here, as soon as you reach 4.5 volt minus epsilon, the output is gonna go into positive saturation. Yeah. So as soon as V68 reaches V69, which is equal to 4.5 minus epsilon, V67, the output goes to positive saturation, 9 volts. So it looks like this. It went down, now it goes back up. And what happens to V69, which is the reference voltage? It goes back, it was at 4.5 volt minus epsilon. It goes back to 4.5 volt plus epsilon. And what happens to V68 at the capacitor? It was here, so it was discharging, and now, boom, it's recharging. So it would like to go all the way to 9, but it stopped here because it's reaching the 4.5 volt plus epsilon. So as soon as V68 reaches V69, this one, V67, the output goes to negative saturation. So it's gonna go like 0, and then it's gonna keep doing this. So that now it's gonna go back, down, go back. So that's your Astable multivibrator output right there. That's that square wave. V69 is a square wave that's gonna oscillate between those two values, which are relatively close to each other. And at the capacitor, V68 is gonna pretty much look like a sine wave, almost. So I think I'm gonna stop here. I mean, there's not much else to say about it. So I'll see you around. Bye.